Still section 1.3 on polynomials. We just did adding and subtracting. I stopped it with that. Into a second video here to give you kind of a break, and we're going to look at multiplication. So this will be a little bit shorter. Distributing, again, very useful. We use it a lot. When you're distributing through the parentheses, it doesn't matter how many things are inside the parentheses. We can still distribute. In this case, we do have some variables, though. I told you earlier in an earlier video that when you're adding or subtracting, don't worry about the exponents because they don't really matter as long as they're the same. We're combining like terms together, and that's absolutely true. When you're multiplying, it's a little bit different. Multiplying is different than adding. I know that seems obvious, but it's a completely different question. It's a completely different idea when you're multiplying. You're asking how many groups of these things are there. You're not just putting them together to form one bigger group. As an example, if we're doing 4x plus 4x, we get 8x. 4x times 4x is very different. We're not adding those x's together to get those x's again. For this example here, this first one that I have, when you're distributing that 4x through, we do multiply the constants together, the coefficients together, I guess I should say. 4 times 6 is 24. X times x squared, if you remember back to our rules of polynomials, or not polynomials, sorry, our rules of exponents, when you're multiplying when you're multiplying powers that have the same base, you add the exponents together. So x to the 1 times x squared is x to the third power. So 4x times 6x squared would become 24x to the third. 4x times negative 7x, negative 28x to the second power. And the last one, 4x times 2, we'd have 8x. So when you're multiplying through the parentheses with exponents, with variables, remember your exponent rules, those exponent properties that allow us to multiply powers together. Same thing with this. We've got negative 3x times 8y squared. Now, x's and y's are different, so we would not add 1 and 2 together here because they don't have the same base. They have different bases, which means we can't do anything with that. So this first term would become negative 24xy squared. The second term, negative 3x times 4y, again, x's and y's are different, so become negative 12xy. For the next term, x times x, now we have the same base. So we're multiplying powers with the same base. And we get negative 3x, or excuse me, positive 3x squared, because a negative times a negative is a positive. And negative 3x times 5, we multiply those coefficients together, and we would end up with negative 15x. So again, the xy squared and the xy here is because x's and y's have a different base. So we can't combine those exponents together, and we're stuck. There is no official right way, whether you put the x first or the y first. I think most people put the x first because it's alphabetical. But just to clarify that, it could be y squared x. It doesn't really matter. I think it's just common to put the x first because it's alphabetical. Okay, multiplying polynomials. Again, really more distributing. We use this all the time, distributing. I'm going to move over to the document camera, and I'm going to work through this problem. I'm going to work through it in two different ways. Some of you may have heard or used a method called FOIL, first, inner, outer, last. I'm not going to do that right away. I'll show it, but that is not some very specific master perfect way to do things. In fact, it really falls apart as soon as you have anything more than a binomial, where you have two different things. So as soon as you get something bigger than a binomial like this, FOIL is worthless. So I'm not going to talk about FOIL. I will show it just to show it, but let's look at it a different way. What we really have here is we have two distributions. We've got 3 outside of these parentheses, so we can do 3 times 4x and 3 times 5. And we have 2x times 4x and 2x times 5. We're really distributing twice. So we're going to do 2x times 4x. We're going to distribute that 2x through to everything inside those second set of parentheses. And then I'm going to distribute the 3 through.
So I'm just distributing twice. And if there were three things, if these were two trinomials, you distribute three times. If there were four things, you're just distributing. That's all it is. 2x times 4x is going to give me 8x squared. 2x times 5 is going to give me 10x. 3 times 4x is going to give me 12x. And 3 times 5 is going to give me 15. Now, at this point, I should check to see if I can combine anything together, if there are any like terms, and there are. When you are multiplying two binomials together, you will most likely have some terms that can be combined together. So here I have a positive 10x and a positive 12x. Again, when I did my boxes, and you don't have to do boxes, when I did my boxes, I do want to double check that the operation before it, the add a plus and the plus are stay with the 10 and stay with the 12. So I know if anything's negative, it's not. So I'd have 10x plus 12x is going to give me 22x. So I'd have 8x squared plus 22x plus 15. And that's how we can distribute and multiply two polynomials together. Going back to my screen here, I mentioned we'd have multiplying polynomials and FOIL. So here's your FOIL. I am going to show it just to show it, but again, I won't use that term because it's less effective once you get past these basic problems. So if you use the same problem, 4x plus 5, there we go. FOIL says that you do the first term times the first term, and then, let's see, it was FOIL. First terms are outside terms, so 2x times 5. This is looking similar, familiar. Inner terms, those two being multiplied together, and L, the last terms. Well, would you look at that? It's the exact same thing. Except FOIL, you actually have to remember, what does the F mean? What does the O mean? Which order do they go in? Is it oil? Oilf? What is it? Loif? And it doesn't actually matter. It could be loif, L-O-I-F. You'd still get the same result because it's distributing. So if you want to use FOIL, go for it. There's nothing wrong with FOIL for multiplying two binomials together. I won't use it very often, if at all. But if I say FOIL it out or expand it out, this is what I'm talking about. So that's FOIL if you choose to use it. First, outer, inner, last. Or you can just do what I did here and distribute. Distribute to everything, distribute to everything. Same idea. Okay. Some special cases, because they're special. Some special cases. This one, it's a shortcut, and it's somewhat useful if you're going to do a lot of binomials. So if you're going to be doing a lot of this FOIL stuff, shortcuts are great. They're great if you can do it a lot. If you're not going to do a lot of problems after this class, then it's not really necessarily a useful thing to keep in your brain space. So I'm going to go back to that document camera. I'll do this a lot. So it's 3x plus 7 squared. 7 squared. If you expand this, if you write it out, squared means we take whatever this is twice. So this says 3x plus 7 times 3x plus 7. Now we can distribute. 3x times 3x, 3x times 7, 7 times 3x, 7 times 7. We get 9x squared plus 3x times 7, so I'm going to get 21x. 7 times 3x, another 21x. 7 times 7, I'm going to get 49. What ends up happening in these situations where you have what's called a perfect square polynomial, where it's the same thing twice, it always works out that the first term, this 3x, is multiplied by itself. 3x times 3x. So we always end up getting that first term squared. 3x squared. It always works out that the last term, 7, is multiplied times itself. 7 times 7. Always happens. So we end up with this last term over here, 7 squared. And the middle is always these two terms multiplied together 2 times. We get 3x times 7 and 7 times 3x. So it's going to be a repeat. It's going to be the first term times the second term twice. 2, 3x times 7. We'd end up with 9x squared plus 41x plus 49. So the shortcut, and you can always just expand it out. Like there's nothing wrong with saying, okay, I can do this, write it twice, distribute, get your answer. The shortcut, if you choose to memorize it, looks like this. If you have something plus something squared, like we have here, 3x plus 7 squared. You have something plus something squared. And you want to take the shortcut. It's going to be the first term squared, so we saw here. That's an A, not a 9. The last term squared. That's what we saw here. 7 times 7, 7 squared. And in the middle, the two terms multiplied together, A times B, twice. So it's A squared plus 2AB plus B squared. Now, I will not ask you to memorize that. You do not have to memorize that. It's not going to come up on a test in any way. However, it is a nice shortcut. If you're gonna see this a fair amount, this is a nice thing to have memorized just to be faster. But you can always expand it out. You can always write it twice, do the distribution, combine things together, and get the same result. It's just this is a shortcut. This is a faster way of doing it. One of the reasons that I talk about it, because I just said it's really not essential for you to know this, is that I want to make very clear that A plus B squared, what we just did, is not the same as A squared plus B squared. This is wrong. It would be great if that worked. If it was just, oh, A plus B squared is A squared plus B squared. No, it's not. And please don't do that. It's a really easy mistake to make. Lots of people try and make this mistake because it would be nice if it worked that way. But this is why Batman is hitting Robin, because you can't do that. So Batman is correct. A plus B squared is A squared plus 2AB plus B squared, what we just wrote down a minute ago. It is more complicated than simply A squared plus B squared. Please don't make the simple mistake that everybody makes. I mean, or lots of people make, but be very conscious of that. So I'm pointing it out now because I don't want you to make this mistake, but avoid making that mistake. Expand it out if you forget the rule. If you forget the shortcut, just expand it out and redo it. This one is important that you are not important, but it's very beneficial for you to memorize this one. So if you were going to write something down, if you were going to keep this in your memory bank somewhere, this is the one to keep in your memory bank. This is called a difference of perfect squares. So if you have the same thing, 4x and 2, except that one is adding and one is subtracting, if that's the case, this works out really, really well, really, really nice. And this is going to come up a lot in some of our future lessons. So this shortcut is going to be very useful for you to have in your memory. So if you have 4x plus 2 and 4x minus 2, we call this the conjugate, where it's the same thing except one's adding and one's subtracting. The way this works out, if you distribute, I'm going to go a little bit faster here. We have 16x squared minus 8x plus 8x minus 4. These terms that are in the middle here that we can combine together, minus 8x plus 8x, cancel the 0. They add the 0. So what we're left with, 16x squared minus 4. And this is why it's called the difference of perfect squares. It's subtraction. 16 is a perfect square, 4 times 4. 4 is a perfect square, 2 times 2. X squared is a perfect square, x times x. So we have a difference of 2 perfect squares. And that works out to be the same thing, one adding and one subtracting. So if you see these conjugates, something plus something and the same thing minus the same thing like this, we can skip the middle step and say, well, it's just going to be 4x times 4x, 16x squared, 2 times 2 minus 4. So in general, if you have a plus b times a minus b, we can skip to the end and say that's going to be a times a and b times negative b. And there we have it. That's what it's going to work. So that one is going to be is going to come up a lot. I would recommend memorizing that shortcut or that idea or that concept because it's going to come up in future lessons. Okay, that's it for section 3.